Welcome to the lesson on Plan, Do, Check, Act cycle. Upon completion of this lesson, learners will be able to explain each step of the Plan, Do, Check, Act cycle and describe how the PDCA cycle is utilized for implementing corrective and preventive actions. Let's say you want to improve an industrial process. You have discovered a problem that needs corrective actions. How would you do it? Where would you start? What steps would you need to take to ensure your improvement is implemented? All of these questions are answered through the Plan to Check Act or PDCA cycle. The procedures for both corrective and preventive actions follow the Plan to Check Act cycle created by Dr. William Edward Deming and Walter Shewhart. PDCA is a four-step iterative management cycle for process improvement. The cycle can also be referred to as the Plan, Do, Study, Act cycle, Shewhart cycle, or the Deming circle. The Plan, Do, Check, Act cycle was based on the procedures of the scientific method. They are observation, hypothesis, experiment, and evaluation. Because learning and process improvement are always continuous, it is important that the PDCA cycle be done repeatedly. The steps of the PDCA cycle are represented in a circle to illustrate that it is a continuous process. The process for implementing corrective and preventive actions, abbreviated as CAPA, should follow the PDCA cycle. First, you should plan, document, and analyze the problem and its cause. Second, you should do and implement a solution. Third, you should check and evaluate the effectiveness of the implemented solution. And lastly, you should act and ensure the solution's permanence. Each portion of the Plan, Do, Check, Act cycle is discussed in more detail on the next slide. First, the plan portion of the cycle must start with the identification of the problem. After the problem has been identified, data must be collected and analyzed to determine the severity of the problem and whether or not it should be addressed. If it should be addressed, then a set of expected goals should be developed by the CAPA team. Next, the problem must be documented and analyzed through root cause analysis to determine the true cause of the problem. Once the true cause of the problem has been determined, a solution to the problem should be established. This occurs in the do portion of the cycle. Typically, multiple potential solutions will be discovered, and the best solution concept must be selected. The solution should then be implemented and communicated to all employees affected by the implementation changes. Next, in the check or study part of the cycle, the implemented solution must be observed and evaluated to determine whether or not it was an effective solution. This determination should be based on data and evidence, not opinions. The collected data should be compared to the original goals and expectations of the project, documented in the plan portion of the project. Lastly, the act portion concludes the cycle. If the solution was effective, then a permanent implementation of the solution should be put into the system. Employee training should be changed to include any new procedures or processes. If the solution was ineffective, then the refinement process should continue, and the Plan, Do, Check, Act cycle starts over again. Let us take a look at how the PDCA cycle is implemented to address issues in EV production. Consider a scenario where EV customers reported high motor noise during highway driving. This quality issue needs systematic investigation and resolution through the PDCA cycle. During the plan phase, the team collects noise data and performs vibration analysis to design a new motor mount system. In the do phase, they install redesigned mounts on 100 test vehicles. The check phase involves comparing customer feedback and noise measurements over 30 days. Finally, in the act phase, the successful mount design is implemented across the production line and service bulletins are updated. In summary, CAPA processes utilize the PDCA cycle, founded on scientific methodology. The cycle's circular representation symbolizes its continuous nature, emphasizing ongoing improvement. Organizations achieve sustained product quality by repeatedly implementing this cycle. Thank you.